Hey guys, today we're going to be talking about synthetic division. It's related to long division as it's going to be used for the same thing when dividing polynomials, but it's just a different approach. The only difference with this approach is that we can only use it when we're dividing by a number. So this warning is very good. Please pay attention to it. It's very useful. This is just talking about when we have x plus or minus a number, and that means we can use x plus 2x plus 3x plus 100, but it can't be 2x plus 3 or 3x minus 1, something like that. So that's when we can't use it. So as you see to the right, I have a step-by-step process of how synthetic division is going to work. We're going to reference back to this guy, so just please pay attention to that. And so let's get started with our first example. So for our first problem, I've already given you kind of what's going to happen for synthetic division. So in our first box right here, we have -2, and that comes from this, our division function. So if we want to figure out what this number is going to be, it's really just if we had x minus 2 equal to 0, and we're solving for x. So -2 comes from solving for x when we have x plus 2. All right. So now we're going to move on to our coefficients. So as we read our steps, we have write coefficients of p of x. Need a coefficient for every degree. Use 0 for missing degrees. So let's just move on to this. So for our first one, we have 3x to the 5th. So that means we're going to write a 3 right here. All right. And then our next one would be x to the 4th. So let's see if we have x to the 4th. And we do. For x to the 4th, we have -1. And then now we're going to look for x to the 3rd. Well, I don't see x to the 3rd in our equation, so we're going to write 0. And then now we have x to the 2nd. Well, x to the 2nd, that's not in our original, so again, we're going to write 0. And then now we have x to the 1st. X to the 1st is going to be right here, and that was -5x, so we're going to have -5 as our number. And then lastly, we have x to the 0th, and we know that anything to the 0th power is going to be 1. So it's like we had a constant times 1. But this will always be our constant otherwise. So our constant is 10. So now we have all of our coefficients written down. So now we can start doing a little bit of math. So let's look at our steps. So we're going to bring down the first number. That's our first step. So our first number is 3. So we brought it down. Now our next step, multiply by box, add to next column, repeat. So multiply by box. 3 times -2 is -6, and we're going to add to next column. So -6 goes right here. So then we have -1 plus -6, which is -7. Now we're going to do the next one. We have -7 times -2, which is 14. Add to next column. And then 14 plus 0 is 14. Again, so we have 14 times -2. 14 times -2 is going to be -28. So then we have 0 plus -28, which is -28. And then we do -28 times 2 again, and then we're going to get 56. So then we have -5 plus 56 is going to be 51. And then we are going to do 51 times -2, and that is going to be -102. So then, when we get to this point, our last number is going to be the remainder. So we do 10 plus 102, and that's going to be negative 92. So that's our remainder. But that's not it. This is not where we stop. Where we stop is where we're going to write our answer. And our answer is going to be a new polynomial. So we have 3. And then when we look at our last step, it says our answer starts 1 degree less than original. So it's going to be 1 degree less. So that means if we have x to the 5th, we're going to start at x to the 4th. So 3x to the 4th minus 7x to the 3rd plus 14x to the 2nd minus 28x plus 51. And 51 is our new constant. And then lastly, we say we have a remainder, or just put r, is negative 92. And that's our answer. All right, so now here we have a new problem. We have x to the 4th minus 3x to the 3rd plus 5x minus 6. And this time we have to write our coefficients. So first, I'm going to find the box. So my box, we have x plus 2 equals 0. Solve for x, we get x equals negative 2. Negative 2 goes in my box. All right. So now I'm going to write my coefficients, and we're going to start with x to the 4th. X to the 4th is 1. X to the 4th has a coefficient of 1. Now I'm going to move on to x to the 3rd. X to the 3rd has a coefficient of negative 3. Then our next one would be x to the 2nd. Well, x to the 2nd doesn't exist on ours, so we have 0 as our coefficient. And then we have x to the 1st, which is right here. So we write 5. And then we have our constant, which is negative 6. So again, I'm going to look at my steps, and we did number 1, so now let's do number 2. Bring down the first number. My first number is 1. Next, 3. We have multiply by box, add to the next column, and repeat. So we're going to have 1 times negative 2. Well, that's going to be negative 2. And then we're going to add, so negative 3 plus negative 2, that's going to be negative 5. Then we're going to multiply. Negative 5 times negative 2, that is going to be 10. 10 plus 0 is 10. Now we're going to multiply again. So we have 10 times negative 2, and that is going to be negative 20. I wrote 10, sorry. Negative 20. And we're going to add negative 5 plus negative 20 is going to be negative 15. And then negative 15 times negative 2 is 30. Oh, I did it again. 30. And the negative 6 plus negative 30 is going to be negative 36. Then lastly, we're going to write our answer. So we're going to start with our first one. And remember, we're going to start 1 degree less than the original. And our original is x to the 4th, so we're going to start with x to the 3rd. So we have x to the 3rd, and then we have negative 5x to the 2nd. Then we have plus 10x, and then our new constant is 15. And then we have a remainder of negative 36. So this next one, you might be thinking, this is kind of different. Well, it means the same exact thing. It means x to the 3rd plus 5x to the 2nd minus x minus 9 divided by x plus 2. So again, I'm going to solve for x. So then I get negative 2. And remember, this might not always be -2. I know a lot of these happen to be -2, but remember, it will not always be -2. So now I'm going to start writing my coefficients. So let's start with x to the third. So x to the third, we had 1, and then we go to x to the second. Well, x to the second has a coefficient of 5. And then now we go to x to the first, or just x, and that has a coefficient of -1. And then lastly, we have our constant, which is -9. So following our steps, bring down the first number. So bringing down my 1. And then now we're going to multiply by box, add to next column, and repeat. So multiply by box, 1 times -2, that's going to be -2. Add to next column, 5 plus -2 is going to be 3. 3 times -2 is going to be -6. So then -1 plus -6 is -7. -7 times -2 is 14. So we're going to add it to our -9. -9 plus 14 is going to be 5. So now we are going to write our new polynomial. And we're going to start at x squared because we're going 1 less than x cubed. So we have 1x squared because our coefficient is 1. And then plus 3x minus 7. 7 is my new constant. And then we have a remainder of 5. And that would be my new polynomial. So here is my next polynomial. I want you to try this on your own first. So pause the video right here, and then I will show you the answer. So please pause the video right now. So for this one, you should have gotten x to the third minus 4x to the second plus 14x minus 36 with a remainder of 82. And if you didn't get this answer, go back and check your work. Make sure your numbers match mine. And also make sure you're also multiplying by that -2. So, and multiplying by that negative number can really mess things up. So really make sure you're keeping track of the signs that you should be using. So here's the next one I want you to try by yourself. It's a little different and a little out there. So I want you to try it by yourself first. So I'm going to pause the video here and just see if you can do it by yourself. I'm really curious. So for this one, you should have gotten x to the fourth plus x to the third plus x to the second plus x plus 1 with a remainder of -1. And that kind of brings us into my next subject with these two theorems that you need to know about these functions. Okay, so let's look at factor theorem first, because that's a little bit easier to understand right now. So it says if P of A equals 0, then x minus A is a factor of P of x. And this is a very important theorem to know because it says something really important. So if you get a remainder of 0, that means x minus a number is a factor of P of x. So let's look back at number 5, the one you did by yourself. We got a remainder of 0, so that means x minus 1 is a factor of x to the fifth minus 1. So that's what factor theorem means. So anytime you get a remainder of 0, that automatically means your division is a factor of the original polynomial. So now we have remainder theorem. The value of the polynomial p of x at x equals a is the same as the remainder when you divide that polynomial p of x by x minus a. So you're probably thinking like, Ms. Smith, that doesn't make any sense. So let me describe it really quick. So all that means is, let's go back to number 4, the one you did by yourself, is when I put -2 into our original equation, this guy, you will get 82. So let's look at the next one. If I put -2 And to my original, I will get